Section 6.1, Polynomial Functions. In this section, we're going to talk about polynomials and how to classify them by their degree and by their number of terms. So we're going to start the section by talking about polynomials and how to first make a polynomial. And that's going to start with the monomial. The monomial is the most basic form of a polynomial you can have, and it starts with either just a number, a variable, or a product of variables and numbers. If you're going to use a monomial, one of the easiest ways to kind of describe to you the difference between a monomial and what's not a monomial is to give you some examples and then some non-examples. So according to my definition, a polynomial can be something as simple as just a number by itself, or a variable by itself, or any kind of product of those things. So a product of those might be, like if I put that together, that would be 5x. Or you can even include whole number exponents, which means the exponents have to be like 1, 2, 3, 4, something like that. Because again, an exponent is a form of multiplication or a product. So I could have something like 4x squared. You could have fractions as long as the fractions are just the coefficients. So you could have something like 1/2 x. You could even have like 3x over 2, right? Because I could rewrite that as 3/2 times x. So then for non-examples, there's really a couple of things that you can't do to make a monomial. One of those, because it says it has to be a product, would be division. So in other words, I can't use something like 4 over x as a monomial. Can't have that division by the variable part. And then something else that would not be an example is, again, because it can only be a product, we wouldn't be able to do something like the square root of x plus 3, because that would not give me a whole number exponent. It would give me simply a fraction or a rational exponent. Okay, so those are the monomial parts. And when we put the monomial parts together, we actually end up with a polynomial. So a polynomial, like I said, can be as simple as a monomial by itself or the sum of monomials. So that might have something like, let me get my pen on here, 4x plus 3. That's a sum of two monomials, a 4x plus a 3. You could have x squared plus 5x minus 7. That's a polynomial. You have all these individual monomials like x squared, 5x, and negative 7. Those are all monomials combined together to make a polynomial. Now, down here I have this description of a polynomial function, which looks kind of scary, but really it's not as terrible as it looks. All these little subscripts and things are just indicating that I have different coefficients for each of my terms. Okay, it says all the exponents are non-negative, okay, so they all have to be positive integers, and the coefficients are real numbers. So this is just simply saying I have a coefficient with x to a power. Then I have a new coefficient on the next variable with a different power, and all the way on down until I have a coefficient with x to the first power, and finally a constant. So you have all these, and you can go as many terms as you need. That's why these say n and n minus 1. Okay, so just like I've had here, so this doesn't change anything about my examples. I could have, I'll just make one kind of large one, but basically if you started with like something like 3x to the 5th power, then you might have minus 2x to the 4th power plus 3x to the 3rd power plus x squared minus 5x plus 2. Okay, and you'll notice that in this, it starts here with the exponent 5. That would be like n minus 1, n minus 2, all the way down until you get to x and your constant. And then again, these are just my different coefficients. So I got a negative 5, I got a 1, I got a 3, a negative 2, and a 3. And that's what these right here correspond to. Okay? So now that we know what a polynomial is, let's talk about actually classifying it. So when I classify a polynomial, I'm going to classify it by degree, and I'm going to classify it by the number of terms that I have. And so when I classify by degree and number of terms, I'm actually going to end up with using the exponent on the variable. So when I use the exponent on the variable, for example, like here, my exponent is 3 and 2. That's a 1 and a 0. So let's write that down. So if I have exponents here, this would have a degree of 3. This one would have a degree of 2. The next one has a degree of 1. And this one has a degree of 0. So according to my degree of a polynomial, I'm going to take the largest degree for any of the terms. So out of my degrees that I have here for each term, the largest degree I have is 3. So according to this, I would say that this polynomial is a third degree polynomial. Okay, let's do the same thing over here with this one. If I look at each term, this one has a degree of 4, this one has a degree of 2, this one has a degree of 1, because that would be x to the first. And then this last one here, this one's a little bit tricky. According to my definition, the exponent has to be on a variable, right, to be a degree. This exponent is not on a variable. I could actually calculate 2 to the 5th and write that out as a number. So technically here, my degree is still 0, even though you see that 5 up there. So now as far as the degree of the whole polynomial goes, the entire polynomial would be considered a 4th degree polynomial because my highest degree would be 4 right there. So the standard form of a polynomial is to write the terms in descending order by degree, which means from biggest on down to smallest, which is how these are written up here at the top. Okay, so if I'm going to classify them, there's two things or two parts to classifying the polynomial. We're going to classify it by degree and by number of terms. And by degree, we have several names that we're going to use. And again, we just showed you how to find the degree of the polynomial. We're not going to do each term, we're just going to do each polynomial as a whole. So on degree, we start with a 0 degree. Okay, a 0 degree, we have actually looked at these before. 0 degree is called the constant. Okay, so a constant is just going to look like a number. Pick a number as an example here, we'll use 7. For first degree, we're going to call this linear, right? And we've seen those. A linear term is going to be something like 3x. Then you have this second degree, which we've worked with those two. We just did that in chapter 5. And those are called the quadratics. So those would look like, let's make it 5x squared, something like that. Okay, now these next ones are ones that you may not be familiar with. The third degree is called cubic. So if something to the third degree is going to be like x to the third. A fourth degree is called a quartic polynomial. Just think of 4 quarters in a basketball game or 4 quarts in a gallon, right? So you got quartic might be 6x to the 4th, right? Then 5 is quintic. Okay, so 3x to the 5th. And then anything that's 6 or more, you're just going to use the number of the degree. So you'll just say it's a 7th degree or a 12th degree or whatever the case may be. Now, as far as actually naming the polynomial by its terms, you've actually heard me use these terms in class, but we haven't officially talked about what they are. If there's only one single term, we actually talked about that already in this section, that's called a monomial. So a monomial will look like, and it doesn't matter what degree it is, it just has one term. Then two terms, we talked about these a lot in the last chapter, is called a binomial. So two terms is going to typically look like something like 4x plus 2. Your two separate terms with your plus sign there in the middle. And then we also use this terminology in chapter 5 as well. This is a trinomial, right? You got three of them. So that might look like something 6x to the fourth plus 2x squared minus 6x. Okay, so you got three terms. And anything that's four or more, you're going to say a polynomial. So you're just going to use that generic polynomial with, and then you're going to say the number of terms. So if it had 5 terms, you'd say it's a polynomial with 5 terms, or if it had 4 terms, a polynomial with 4 terms. All right, so let's take a look at a couple of examples here. So for my examples, I am going to go ahead and put these in standard form, and then I'm going to decide how to name it by degree and number of terms. So for A here, I'm going to end up with negative 7x plus 5x to the fourth. In standard form, that's going to look like this. Largest degree first, 5x to the fourth minus 7x. So there's my standard form. Pretty simple on that one. Now to name it, the largest degree is 4th degree. So I'm going to call that quartic. And it only has 2 terms in it, right? You've got 5x to the fourth and you've got negative 7x. Those are my 2 terms. So that's going to be called a binomial. Okay, let's go on to the next one. This one, if I put it in standard form, the largest degree I have here is the third. So I'm going to start with that. 3x to the third. Then I have a x squared term, so that's going to be plus x squared. Now when I get down to the next term, which would be the x's, I have a negative 4x and a positive 2x. So I want to combine those together into 1, which is going to leave me with a minus 2x. So you don't want to classify until you have everything all in standard form and combined. So this one is actually a cubic, because I have a 3rd degree. And because it has 3 terms, we're going to call it a trinomial. All right, so the last one is this one down here. And we're going to have the largest degree is 5. So let's start with that. 2x to the 5th plus, then it looks like I'm going to have to jump down to a 3rd. And I've got 3x to the 3rd and 2x to the 3rd. Both positive, so 5x to the 3rd. Then it looks like x squared. And then finally minus 4x. So if I'm going to name this one, largest degree is 5. That makes it quintic. And it looks like it has 1, 2, 3, 4 terms. So I'll say quintic polynomial with 4 terms. Okay, so what I need you to do is make sure you check the description in the notes that's posted here online, and bring that with you to class along with your notes for your homework assignment.